see, hopefully that goes there. Okay, so if we're given a parabola, and our first parabola is f of x equals x squared minus 16, and I asked you to sketch that function, we should be able to sketch that quite quickly and easily. Firstly, is it a happy or a sad parabola? Well, we look at this a value in front and go, well, it's a positive here, therefore it's a happy parabola. What does the negative 16 do? It translates it down, so it moves it down. So we already know that if we kind of in our head we're going, well, it's a happy parabola, and we know that this minus 16 means that it's moved down, so it's gone there, which means if we drew in our axes, it would look something like that. And these intercepts we'd actually be able to say quite quickly are -4 and 4. So if we drew this, that's the process we'd go through. And I kind of expect you to be able to draw parabola quite quickly, where we've got that. So let's draw our axes and draw a neat version, where this version on the right was just something that we're doing as a practice in our head. Let's make this a bit bigger and say, okay, well, x squared minus 16, we know it's a happy parabola and it's moved down by 16. So there it is there. We're going to label our graph f. And if we wanted to work out what the y-intercept is, we could just read it off to go, well, it's -16. But more formally, we know that at that point, the x value is 0. So f of 0, when our input is 0, what is our output? 0 squared minus 16, which just gives us our -16. So therefore, this is -16. And this is going to become important this year, because we're going to move this left and right. We're not going to be able to just read it off our graph straight away. We can't just look at the equation and go, oh, -16, -16. We might have to substitute 0 in. And then if we wanted to find our x-intercepts, we know that for our x-intercepts, the y value is 0. We know that the y value is 0. So we just take our function and make our y value 0. So instead of f of x, we're saying 0 equals x squared minus 16. So when the y value is 0, what's the x value? And now we've got an easy quadratic, and this is how we started our year. Remember, we're solving these types of equations, and I said, think of the parabola, think of the parabola. This is y. So that we could add 16 to both sides, or we could factorize. I'm going to factorize. X squared minus 16, difference of two squareds. Well, bracket, bracket, x, what times what? Well, it must be 4, it's going to be a positive, negative, and therefore we've got our two intercepts from this. X equals -4, that relates to this intercept, and our other solution is x could have equaled 4, so this relates to this intercept. Okay, so that's sketching of parabolas, something we can probably do fairly comfortably. Now I'm going to give you a different parabola, and I'm going to give you the parabola that has the equation g of x, let's give it a new name, is this time it's x minus 3 squared minus 16. Okay, so it still looks like a parabola. It's still something squared minus 16. But our function's going to look a bit different now. And in terms of our rough sketches, it's still a positive because there's a positive in front here. There's a 1. So we know that it's a happy parabola. We do know it's moved down by 16. That's what that 16 does. So we do know it's gone down by 16. And now the new bit is, what is this -3 doing over here? Let's run through our process like we did for the other one. And we're going to put our axes over here because we don't quite know what our graph's going to look like. We haven't seen something, or I'm assuming you haven't seen something like this before, where it's now x minus 3 all squared. We're not going to multiply this out. We're just going to try and work out, let's try and solve this. So to find out what our y-intercept is, we said that all we needed to do was input 0. So if we input 0, g of 0 equals 0 minus 3 squared minus 16. So in other words, when we input 0, what's our output going to be? What's our y-intercept going to be? We know it's going to be down here somewhere. And let's work that out. 0 minus 3 is minus 3. Minus 3 squared is 9. And I wouldn't even bother doing all of that in my head. I'm sure that you've got your calculators out and just said 0 minus 3 squared minus 16 gives us negative 7. Really no need to work that out in your head, and you get negative 7. In other words, when the input's 0, the output's negative 7. And I think it's useful to write it as full coordinates like that, so we know that there's a point here that is 0, negative 7. But our graph doesn't just look like this, and this is why I'm saying, look how it's negative 7, it's not negative 16. What are our x-intercepts going to be? Well, to find out the x-intercepts, we just make our y value 0. So we say 0 equals x minus 3 squared minus 16. There's an equation to solve. So go for it. Let's try and solve it. Okay, so I'm leaving you to solve it. So I imagine the easiest way that you're going is saying, well, let's just square out this bracket, minus 16, and then factorize. And I'm going to do that as one method as well. So 0 equals, well, that's x minus 3 minus 16. Okay, 0 equals x squared minus 6x plus 9 minus 16. Okay, we've got 0 equals x squared minus 6x. That's the same as we had over there. Must be negative 7. So 0 equals factorize x minus 7 Okay, so we got our two solutions. X equals 7 or x equals negative 1. And let's just check if we substitute it into this equation. 7 minus 3 gives us 4. 4 squared minus 16 gives us 0. Or negative 1. Negative 1 minus 3 is negative 4. So that squared is going to give you 16. So 16 minus 16 equals 0. So we've got our 2 here. We've got 7. So that's gone over here. And we've got negative 1. And the turning point is going to be down here. And we're not going to discuss turning points just yet. We're going to go into that next week. But for now, if we've got a parabola and we know that it's a happy parabola, the only way we can draw it is to draw it through those points, and there's our parabola G. Turning point there somewhere that we're going to work out. Intercepts were negative 1, 0, and this one here is 7 and 0. Now let's just look at what this has done, this negative 3. Here's our original parabola. Its intercepts were at negative 4 and 4. This parabola is exactly the same shape, but all we've done is we've moved it right by 3. Notice that it was negative 4, and now this intercept is at negative 1. This intercept was at 4, and now it's at 7. So all this does, and kind of a way to think of it, is to go, well, it says negative 3, and so it sort of does the opposite of what you would expect. It doesn't move it left by 3, but it moves it right by 3. So here's your translation. Here's your shift. So our graph moves right by 3. In other words, if we had our original function, x squared minus 16, and we took that graph and we just moved that graph right by 3. So we just moved it and did this. This graph would be g from below. That's all that this negative 3 does. This negative 3 moves that same graph across by 3. So we didn't actually have to do all of this working out because we knew that the intercepts of x squared minus 16 were minus 4 and 4. So we know that this graph's just moved right by 3. So I'm going to run through one more example to show this. So I'm going to look at a graph that looks like ones we've seen before and then show how a horizontal translation does it. Just making sure that that PDF's saving on the website at the same time. Okay, so let's consider two more functions. Let's look at f of x equals minus 2x squared plus 18. And our second function we're going to look at is g of x equals negative 2. And in this case, we're going to say x plus 1. So based on what we saw in the first function, if we subtracted 3, so if we went in our previous one, we said x minus 3, the graph moved right by 3. So if we see something that goes x plus 1, kind of going to do the opposite of what we thought. So it said plus 1, so it's not going to move right, it's not going to move plus 1, it's actually going to move left by 1. So let's draw these graphs and see. And we're going to draw them on the same set of axes. So I'm going to do it over here, and we should have enough space as well. So we got our x, we got our y. Yes?
So that thing next to the plus 1 in red, is that an x?
Yes.
Yeah, I also couldn't see what it was.
Let me...
Weird shape.
That's a weird shape. Okay. How about I do this? For these ones, I can go... Hello. G of x equals minus 2x plus 1 squared. How's that?
Yeah, a lot better.
Cool. And then I'll just... rub those out. I really feel like I'm in the classroom. You're moaning about my writing. Okay, so there's that one there, and I'll maybe fix up the other one, but the other one's hopefully clear enough. So it's the same function. All we've done is instead of x, we replaced it with x plus 1. So we're expecting that it's going to move, and maybe give ourselves a bit more space there. It's just going to be that same function and move left by 1. So let's concentrate on f of x and what it looks like. We know that its y-intercept is at positive 18. We know that it's up here. And we know that it's a sad parabola because it's negative 2. So already know that it's going to look like that. And if we wanted to work out the x-intercepts, well, for the x-intercepts, we know that, and let's just put in here 0, 18. We know that the y values are 0, 0. So we're going to go 0 equals negative 2x squared plus 18. Okay, well, I'm going to solve this differently and not factorize and go, well, let's put all the x squareds there equals 18. X squared equals 9. So x equals negative 3 or x equals positive 3. So we've got a negative 3 and a positive 3. So let's test our theory and say we think that this graph's going to be the same. It's just going to have moved left by 1. So we think that this one's just going to look like this. It's going to turn over there. It's still going to turn this side. This point here is now going to be at negative 4. This point here is going to be at 2. And this point here we definitely don't know. There's no way of directly seeing. And we know that this point here, this turning point, is going to be everything's left by 1. but we're not concentrating too much on the turning point just yet. But we'll see it's going to be quite easy to read off from the graph if it's in this form. Okay, so let's check it out. For our y-intercept, we're going to need to substitute x equals 0. So therefore, y equals -2, x equals 0 squared plus 18. Punch that in our calculator. 1 squared, 1 minus 2 plus 18 gives us 16. So we know that point there's 0, 16. And these are just our general knowledge of functions, that to find the y-intercept makes x 0. To find the x-intercept, make y 0. So let's do our x-intercepts over here. Now we know that we should get -4 and 2, because we know that I'm basically telling you that the graph's going to move left by 1, because it was +1, so it's kind of doing the opposite. So, but let's check it out. So when y is 0, we need to work out what is the value of x. And for now, let's just go back to our basic algebra that we know and say, let's just multiply this whole thing out and then factorize. So please do it. I'm going to do it here in the background while you're doing it as well. So I've got -2, x plus 1, x plus 1, plus 18, 0 equals
Are you gonna post this video on Google Classroom afterwards?
Yes, I'm going to put it on that website. I'm going to replace that Google Meet part with the video, and that PDF that's on the same page is the same PDF that I'm working on here. Yeah. There's half a chance that the tech fails us at any given stage, so recordings don't come out, but that's the plan. Okay, so we've got -2x squared minus 4x plus 16. You notice the 16 comes up as the y-intercept 16 over here. Going to divide everything by -2.
Oh, so should you times the -2 in?
Yes, so first you square it, because we do exponents first, and then you need to multiply the -2 in. Then I'm either going to rearrange so everything is on the left-hand side, therefore this will be a positive, or I'm just going to divide everything by -2 and have x squared plus 2x minus 8. And then equals, well, this looks like a nice thing that we can factorize. You could always use the quadratic formula, but it feels like overkill for this if it factorizes nicely. Xx probably going to be 4 and 2. No surprise there, that's what we're expecting. Plus 4, -2. So x equals -4. That's what we're expecting. Or x equals 2. So if I gave you this function, this g of x equals -2, x plus 1 squared plus 18, didn't tell you anything about this horizontal shift stuff, you should be able to sketch it, because you just go back to your functions basics, which are, if you want to find the y-intercept, make x 0. Cool, there you found it. If you want to find the x-intercepts, then you make y equal to 0, solve, you get your two x-intercepts, and you already know that the shape's going to be that. And that's what we just want to start with now, is to say, we can sketch the thing, but we also know that it's going to look like this function. But all that, instead of having an x, we had an x plus 1. Plus 1, now we do the opposite, it's going to move left by 1. And you see what I mean by I'm saying the opposite, because it says plus 1, so you think, oh, the graph's going to move right. It's going to move by plus 1. No, it's going to move left by 1.
I don't get that. So like, why does it go left, not right?
So let's substitute a value in here. So if we substituted the number, let's say, 3 into here. So if we substitute 3, we'd have 3 squared is 9. This would be negative 18. Our answer would be 0. So if we substituted 3 into our purple, our f of x, then our output would be 0. In this one, when we substitute 3 plus 1 gives us 4. So putting 3, and then we're going to square it and multiply by 2. But if you put in a number into this function, it's like you've put 1 more into this function. So if I put into this function the number 1, it's like putting 0 into this one, the g of x, because you're going to add 1.
Okay, yeah.
I really think the easiest is just to go, well, it kind of does the opposite. But yeah, the reasoning to kind of try and conceptually make sense of it is whatever you put in this function, the g of x, is like putting in 1 more than you put in this one. So at this stage, we put in 0 and got 16 out. It was like putting in negative 1 into the other function.
Yeah, see.
But yeah.
How would they ask this question? Would they give you the f of x one, and then ask you, looking at g of x, where would the next parabola be? How would they ask the question?
So they could ask you that. They could give you this function and say, write down the equations. So given f of x, write down the equation of the parabola that's moved left by 1, and you could do this. Or what they're really going to do is they're going to say, sketch this function, g of x. They don't give you this function, the f of x. They just give you g of x and say, sketch it. And then we're going to go into a more efficient way of sketching it. But for now, I just want to go, well, to sketch this function, draw on your function knowledge, make x equal to 0, you get the y-intercept. You know that it's a negative, so it's a sad parabola. So you know that it's going to look sort of like this. And you've maybe got an idea that it's like this function that just moved left by 1. And then once you've drawn, because I'm just going to give you 3 to draw for the rest of today and into tomorrow. Once we've drawn that, then we can start looking at things like, and I'll plant the seed here to go, what about these interesting points? Negative 1, this point here, and this turning point. What is this turning point? What is the turning point in this case? We said that it's going to be negative 118. Is there a way to read off negative 118 just from this equation that was given to start with? Is there negative 118 hidden in the equation somewhere? I mean, we said that this does the opposite to what we thought it would do. So this is what we're going to go into on Monday. For now, as I said, I just want you sketching it and doing this and getting back into our algebra. But if the x value is negative 1, look how we had a positive 1 over here. The y value is 18 for the turning point. Look, there's the 18 over there.
Yeah, I see.
And for this one here, this turning point, well, the old turning point was 0, 16. So this one, everything's just moved right. So it's 1, negative 16. Sorry, 3, yeah?
So will we be doing the turning point in depth next week?
Yes.
So will we restart it next week?
So I'm going to give you this function, and so from the 3 functions that you're going to have to draw, we'll use those to look at the turning point on Monday.
Okay.
Yeah. But I wouldn't give you too much and start going into sketching and all of that. Let's just remind ourselves of how do we find intercepts and those things, and then this will all be a whole lot easier as well once we've done that. Okay, so for what I want you to draw, and I'm going to write them up here. We are, let's see if I can do that. It's 10 past 11. I know that this session ends at 11:30, so I'm going to write them here. I'm going to stay on the line, and you're welcome to leave, and then keep an eye because the work's going to come up on Classroom. This will be on the website as well. So I just want you to sketch the following 3 functions. Let's write them up nice and neatly here. The first one is, I've got, and please draw them on different sets of axes. Let's not get them interfering. 1 squared minus 8. Then the next one was g of x equals minus 3x minus 2 squared. And the last one minus 4x.
So
Yes.
is this going to be the homework for tonight or for Saturday?
So it's the work from yesterday. I want to see the notes from you watching yesterday's video that I put up. So, because I don't want you ever just to watch a video and just sit there drink your coffee and make notes. So I want you to take photos of your notes from yesterday's videos, today's notes, and these 3. And then it's just going to be these 3, and that's all that's going to be due for tomorrow.
Is it just the notes and these 3?
Exactly that, yeah. I don't want to put too much up because this we're holding to now. So what you need to do is do those 3 and do them all properly. I don't want to give you too much and then you missed out yesterday because you were still getting all set up and then you're feeling behind already. Sets of okay, and then we'll look at the turning points. Okay, so there's your work. Saved. I'm going to stop that recording. It's going to come out to be quite long. The videos that I make for you should hopefully be a little bit shorter and more succinct. But yeah, I'll put up this recording as it stands up to this moment now.